This is the Amp Hour Podcast, released October 1st, 2017. Episode 362. Secret Squirrel.
Welcome to the Amp Hour. I'm Dave Jones from the EEV blog.
And I'm Chris Gamble of Contextual Electronics.
How's the new job going?
Yeah, it's going great, man. I don't know, I went to Maker Faire over the weekend, and I don't know if that's work.
Which Maker Faire? Sorry, there's so many.
I went to the New York Maker Faire. That's true. There were actually, I felt bad.
I missed
the
that
Milwaukee one.
Huge? Like, you don't sound, I went to Maker Faire, And isn't it supposed to be, ginormous?
It's big. Oh, it's nice. It's great. But what I was saying is, I don't know if that's work. That's what I'm really getting at. You know what I mean? It's...
Right.
I probably would have been there anyways, but...
Right.
Yeah. But I was talking to people
So you officially went there for work?
Yeah, exactly.
So do you guys have a stand or something, or what?
No.
Right. Okay.
I don't like doing that. You've had to do that in the past, right?
Right, but did they send you there to walk around in a T-shirt holding a placard or something? Or
yeah, sandwich board.
Right, a sandwich board, yeah.
That's a good idea, but no, I was just there to talk to people,
Right.
So, yeah.
Okay.
Yeah.
Okay,
yeah,
cool.
So it was good. It was good. It's and actually, I want to announce too. I will be at Open Hardware Summit. I found out, so I'll be out there as well.
Excellent. Is the company sponsoring that, or?
Yeah, we're helping sponsor that.
Okay.
So it's good. It's everything's great.
Excellent.
I don't know. I'm still learning a lot.
Learning. Actually, I looked at you tweeted a kit or something that you could get. It's free or something. You'll send it for the cost of postage or.
Yeah, the Sim.
Something, right, yeah. Okay, that actually looked interesting. I thought, maybe you should, have one of those sitting around just so I
yeah. Well, you know. We're buddies. I'll send you stuff.
Right. Sweet. Send it in the mailbag. You'll get free publicity.
Right, exactly. Yeah, exactly.
You know how the game works.
Of course, right. I know which email address to bug.
Right.
Dave actually reads my emails sometimes. Yeah, but no, it's all good. I don't know. This is I think the interesting thing is I think the thing that's interesting is that my title is developer advocate or developer relations or something like that, which wasn't really ever. That's a software thing, really. That's a software. I know people that have done that for Software World.
Yep.
But that's. But then again, I think about it, some people do that. Usually, it's FAEs are kind of that same role. So
they're basically hardware evangelists or whatnot.
Yeah, exactly. They're kind of showing that stuff off. So I'm looking forward to it. I've got a couple of boards that I'll be making, stuff like that. We use U-Blocks modules. They're real simple in terms of the actual construction of the circuits. It's mostly just doing breakout stuff. But I'll be doing those soon. I'm looking forward to that stuff.
Got it.
Yeah.
So you'll be so it's actually it's not too dissimilar to your old job. You're still gallivanting around the country going to being the face at shows and whatnot, right?
Yeah. Yep. I'm a face, not the face.
Okay. There's other people in the company who do a similar thing?
Yeah, exactly.
Oh, okay. Right.
Yep. So yeah, it's all going good.
Groovy.
Mm-hmm.
Some people will kill for a gig like that, bumming around at hardware conferences and whatnot.
I do some
work.
I do some work, Dave.
Right. Okay.
A little bit, just a little. But yeah, it's going great. What
So
have you been up to?
I have. Hang on.
Oh.
Have you been booting up the hardware and actually playing with it? Because I presume before you joined the company, you hadn't played with this stuff before.
I had done a little bit, but yeah, this is booting up some of the hardware. I found out the question that you were asking about the sleep currents. You were asking about that.
Right.
It's actually 0.5 milliamp, which is seems high, but with cell modems, it's not great. So there's a micro and cell modem on board. So
okay, so can we give a ballpark for a AA battery powered?
Oh, I did that.
Doodad transmitting every minute or something?
So it's 5,000 hours.
GSM.
So it's 5,000 hours if it slept the whole time. But it would be.
Oh, okay. On what? A set of AA's? What batteries are we talking about?
So a AA, I looked that up the other day. It's 2450 milliamp hours in a AA.
Right. Okay. Right.
So you do that math at 0.5 milliamp. I think it's you double that pretty much to 5,000 hours.
You've got to work in power when you're talking
I know,
that because you probably have to boost it up. Right.
But this is also without transmitting, so that doesn't really count either.
Right. No, it doesn't. I mean, the entire product has to be useful. It's got to transmit,
Yeah, right.
But it depends on the application. Some applications are interrupt driven by a sensor and only transmit when, somebody opens the door of your shed or something,
Right.
Right.
Well, and I was asking around about that too, and like doing so you've probably done this before, where it's like, okay, your micro doesn't get as low as you want it to, you could go and just cut off the power rail to the whole thing, right? And so have a supervisory service. If you were really hurting for it, right, you could set up a supervisory circuit. You could then cut off the power rail to the entire module.
If you're incredibly desperate, but micros are so low power these days, it's almost made those supervisory type stuff redundant and power switching and stuff like that.
That's pretty much pulled into the circuit. Yeah.
Yep.
Yeah, it's not lost on me though that more and more of the stuff that, I mean, this is the trend we've been seeing for a long time, right? Of more stuff gets pulled into modules, stuff like that. It's just that, so like I was talking about the top, like the fact that I'm just going to be doing breakouts for modules. It's not like I'm designing circuits at that point.
Right.
It's basically, Lego blocks.
Yeah, exactly.
So it's interesting. But what really is, it's overall, right? So not just looking at what I'm doing, but just in general too. The thing that I keep hearing over and over and over again is from lots of people, it's like, I don't care about the circuit.
Right.
I love the circuits, you love the circuits, we all love the circuits, right? But most people, they don't care. They just want to get that thing done. They just want... They want
to build their widget.
Right, exactly. They want to know that the shed door's open, like you mentioned, right?
Yep.
Yeah.
They want their widget to tweet.
Right. And it's like, we love the circuit stuff, and I still do, and, like all that. But it's interesting, and it's like seeing how that stuff works at a low level. But that takes a lot longer. And like you think about, the Jim Williams app notes, like I look at that stuff. He's got, what's the one with the thermocouples? You know what I'm talking about? He's got this one gorgeous app note.
They're all gorgeous. What are you talking about?
That's true. But the one that I always think of is the App Note 28, right? So he's got a push pull going into a transformer, and it's all isolated, and then he actually has code at the end of it. I'm sure we've mentioned it here on the show before. But you do all this stuff, and now literally these days, I used to use a chip that was just all this stuff in one. It's the thermocouple's linear. It's basically plop this thing down, give it some power, read the registers, you're done, right? Yep. And it's insane. So and then so what do we do here? But most people just care about getting a temperature. So the art of this is lost. But
quite possibly, yes.
Well, I mean, the art of the circuitry is the art, right? That's what it looks like. But at the end of the day, most people don't give a crap. They just want the temperature.
Yep.
So,
everything's a module. Everything's available as a module.
Oh yeah.
These days, you can buy It's just nuts.
Yeah. Well, I mean, we were talking about board modules last time, right? We were talking about those power, the LT3780 or whatever that was.
Yep.
Yeah. So.
Which I looked at, by the way, because we're working on the micro supply again. So we're going through all sorts of chips again.
Oh, yeah? And, any others pop out? That one?
Oh, they did. I won't say. We're having a look at several others.
Well, that's the other thing, though. Now we were talking about this, right? So you talk about now you're trying to be secretive about this stuff. I understand that, but at the same time, it's who gives a crap, right? It's more about can you source it? I'm sure
exactly.
You know what I mean? It's all about supply chain stuff and getting the.
Well, in our case, it's will it actually do the job, right? Because there's no you can't just go out and buy a chip that's a voltage and current adjustable power supply chip that does exactly what you want. It's super stable for all loads. Boom, right? It doesn't actually exist. It should, but it doesn't, right? That's why power supplies are all discrete design. They're discrete op amps, transistors. Because nobody does an off-the-shelf solution. But there are some chips that we've found which were designed for another purpose, which actually act very similar to what we want. So we have to actually test. In theory, they might work and do what we want, but we have to actually breadboard them up and try them.
Right. I see what you mean.
See if we can press them into service for what we want.
Right. So, I've seen that in the past where it was so it was an output stage for a power supply, but then it was an class AB amplifier driver that was actually driving the transistors, right? And it's that's interesting, right? Because you're still, it's still it's pretty linear, right? But it's you're not driving AC signals anymore. You're just cranking those things on. You're opening the taps and either from the positive rail or the negative rail, and you're burning the rest on the heatsink. So,
yep.
But that's the same kind of thing you're talking about, right?
Got it.
Yeah.
So that's going to be interesting to see if it pans out, because you look at these chips and sometimes the devil's in the detail, and sometimes they've got simulation models, and you try it out and you go,
yeah, right. Is it worth breadboarding? Is it worth making a breakout for that kind of thing?
So anyway, we've identified 1 or 2 chips. So
I was gonna say, how's the search going these days? Because I find that. Like the big searches like you're doing here, like these are like higher overarching. You're like trying to find almost like an architecture and a chip, and
it's hard. You couldn't do it. Like we had to actually think, well, maybe what other kinds of chips might do similar stuff, and we had to look at the other areas because you won't find it by Google searching. You've got to switch your brain on and know that these other types of chips do current limiting and they do voltage limiting, and they're in a totally different category. So you won't find them if you go through the
Wait, are you doing motor drivers?
Selection.
Is that what you're doing? Are you using motor driver chips? You are, aren't you? No?
No.
Okay.
Anyway, I'm not going to say. I'm going to keep it a mystery.
Secret Squirrel. Secret Squirrel.
Secret Squirrel. People can that be the photo for today's show? We can have
Squirrel.
Secret Squirrel.
Yeah, I think that's good. Secret Squirrel.
Okay. Yep. Yeah. So it's like you go, like there are other categories of chips, and some of them look not too bad. So anyway,
so when you're searching though, are you searching? So like I've always been a big fan of like the application level side of things. So you're looking almost like you're like looking in automotive, but then you dive down, you look at then like
you've got to look like the first thing you do in the data sheet is look at the top level thing. Does it have say current limiting, for example? Right, and you go, okay, it's got current limit.
Are you reading the marketing pages, Dave? Oh, no.
Well, yes, we do. But that's the way to filter, because you literally have to look through almost every chip in the category.
Yeah, that's true.
Right?
Yeah,
sometimes. So it's, you've got to, you can't spend an hour reading each data sheet. You'd go insane, right? So you've just got to, so we may have actually missed 1 or 2 by doing that.
This would be a good, wiki source, you know what I mean? So we have, a wiki of, possible applications for each chip. You know what I mean?
Right.
That's something you should do. you can do it,
sure,
man.
I'll spend my valuable time doing that.
You got an assistant. Have him do it.
Right, okay. Yep.
Sorry, I didn't mean to call David an assistant. Don't let him hear I said that.
Right.
Yeah. But I mean, that would be something. I've always thought about this kind of stuff in the application space of because especially searching for it too, searching for again, to go back to temperature, right? Think about searching for temperature stuff. I mean, how many friggin' ways are there to measure temperature? There's thermocouples, RTDs. There's all the infrared readers, the junctions.
There's a regular PN silicon junction.
Exactly. I mean, there's just so many different things, and the problem is that when you go and search on a lot of the sites that are out there, right? You search on a distributor site or something. You basically search for the part, right? And then so if you search for thermocouple amplifier, then you're gonna miss all of the the high level module chips that happen to include a thermo, a higher level encapsulated thing. This is always the problem that we run into, I think. So you should do that, man. You should do that. It's a money maker. Right? It's a money maker right there.
Right. I'll be rich and famous. Yeah.
Right.
Fortune and glory, kid.
Yeah, right.
Fortune and glory. Anyway, speaking of modules and everything else, we can segue into, it's more about what we were talking before we got sidetracked onto thermocouples.
Uh-huh.
Segue into what I was doing this morning.
Oh, yeah.
And it's a bit retro.
Okay.
I know you're not really a retro fan.
Sometimes. That's okay.
Anyway, this might ring a bell or it might what? I'm going to ask you a question. I'm throwing him. I haven't told him what I was doing this morning.
This is like a game show now. All right.
It is. Should I ask it in the form of a question or? Should I,
no, let's go for it. What do we got?
All right. Can you name a embedded PC standard before all this modern Arduino and Raspberry Pi rubbish came along?
PC 104.
Oh, he nailed it. He nailed it. He's not a young whippersnapper.
No, well, we've also talked about that on the show before, I think.
Right.
Usually, I think you sometimes bring that up when you talk about Arduino, but my real thing is I remember there was a trade rag that was just dedicated to that. And I remember looking at it being like, what the hell is this? So anyways, why don't you explain what the hell this is? Because that's probably useful. Yeah.
PC 104 is kind of there is a consortium that set the standard, but I don't believe it was ever ratified by IEEE or whoever do standards, right? But it's basically when in the 80s when everyone was using PCs, right? PCs took over the world and everything, and everyone wanted like industrial embedded solutions, industrial embedded. And sure, you could go out and buy your own processor and you could buy your own memory and you could roll your own solution. But people thought, hey, why don't we come up with a PC in a very compact form factor that is designed for industrial embedded applications? So that's exactly what PC 104 is. It is I think it's 98 by 98 millimeter board. It's a standardized form.
By the way, if you don't know,
what?
The first 103 didn't work.
The first 100. Do you
such a lame joke.
It is. Yeah. Do you know why it's called PC 104?
No, I don't.
Because it has 104 pins.
Oh, that makes so much more sense.
Yeah. Anyway, so it basically, so it's a standardized size. It's 90 by 96 millimeters. So the PC 104 standard, in quote marks, defines the outline of the board, it defines the mounting holes, and it defines the board-to-board interconnect header pins. So they're 0.1 inch header pins, and they're in the and they're functionally equivalent to the old PC ISA bus. Right? You remember the old? So they're all available in 8 or 16-bit version, and well, most of them used a 16-bit. And these pin headers, and you could stack the boards just like the Arduino boards and other ones can stack. So they've got the pin headers the headers coming out the bottom of the board, extending out, and then so the male pins coming out the bottom, and the female one on top, and you can stack as many as you want.
Right. Just don't double dip on a pin, right?
Right. Well, it's a standard ISA bus, so within the limits of sharing stuff on the ISA bus. I won't go into details, but that's basically what it is. So it's usually an Intel processor. Back in the day, they were 8088s.
I'm looking at a PowerPC one on Wikipedia right now.
You can get different ones
newer,
these
probably,
days. And they still sell them these days, right?
Oh, yeah.
It started in the 80s. PC 104 standard was early 90s. I was playing with a board this morning, which is an 80386SX board.
80380, so it's a 386. Yeah.
It's a 386.
Okay. Sorry, I was like,
he's got to think about.
Because you said like 803, I'm like, what's an 803? Yeah.
Right.
Sorry. Yep.
Sorry, 8386, or just a 386SX. The SX being the limited 16-bit bus version of the 32-bit processor.
See, I never did anything with 286, 386, 486, like anything except for use it as a computer.
Right, okay.
Right, yeah.
Yep. So, back in the day, I was developing with PC 104.
Oh, wow, okay.
And the good thing about it was a PC. Right, so you're already familiar with the development environment. You could develop it on your desktop, and it just ran.
Yeah, it's just a lower memory, lower whatever.
Yeah,
right?
you just had a limited amount of memory, and
Did you heatsink them usually, or no?
No, because these were like I powered it up this morning, and it only drew 2 watts or thereabouts when it was just idling. And when I plugged in the video card, it used an extra half a watt or something, so they're pretty low powered. So it's on par with like a fully flat out Raspberry Pi at at more than several watts, because the Raspberry Pi can pull 2 amps or something at 5 volts, so that's 10 watts.
Yeah, that's
so so these things didn't need it. Well, the later ones might have need heat sinks, but back when I was playing with them, they were all low power 386 SXs and stuff like that.
What were you using them for? So you were doing like test fixtures and stuff, or more
mobile test jigs and things like that.
Okay.
So and it just made development easy.
Yeah.
And of course you could get digital plug-in boards for them. So you get digital I/O, you could get relay I/O, you could get 8-port RS-232s if you need a bunch of serial ports and all sorts of stuff.
This is going to sound stupid, but were you running DOS programs? Or you weren't running full Windows on there?
DOS. No, DOS. Yep.
Okay. So you were developing for DOS, and then you would just run
developing for DOS and just run a command line program, which yep. So it just
how quaint.
How quaint, yes. But it was great because it was the same as the PC you used. So the development environment was
I think it's gonna be really interesting. Like, so, like, as you know, as Sagan and Hux grow up, like, if they're nerds, which we can only hope.
Yeah, right.
We can like they have a choice. But like, they're like Linux is gonna be normal for them, right? I mean, like,
right, yeah.
That's what's crazy.
But there was no Linux back then.
I mean,
right?
Linux,
there was like
there's Unix for sure, but maybe not Linux.
But
I don't know the history of Linux, but
not Linux as people know it today. Right?
Damn straight, yeah, right. It wasn't included on a $35 computer that you got, that like it's fully functional. Yeah, right. I mean, like, isn't that's crazy to me? So wow.
No. It's Back then, you ran DOS, or you ran what was it? The Novell DOS, the Novell DOS version, which was a better version of Anyway, okay. And then there were other versions of other flavors of DOS which were better designed for embedded ones. God, I can't remember the name now. It's been too long ago.
Okay.
Anyway, the fact is, this PC 104 you can still buy.
Sure,
these boards, right?
My buddy's and he does defense stuff, and they use it like a ton. So
they use it a ton because it's a standard. It's been around for more than 25 years, and you can still get the same board with the same 0.1-inch pin header ISA bus, except they use an Intel Atom processor now, right?
Oh, okay.
Because you can, right? Or you can still get the older ones.
Sure, but you get more power, or you get more processing at lower power, right? So
yeah, exactly. So,
the Atom's not a bad processor. It's just that,
it was
no
bad
good
for a desktop.
I was just in a laptop as well. Like, I remember the little EEPCs. Remember those things?
Right.
Oof.
Oh, yes. I've had one. Yeah, I've got one of those too.
What a piece of crap.
Yeah,
but I mean, like,
it was game changing for the time.
Yeah.
Back, for about a year there, that was a game changing product. The EEPC.
Right.
Right. So yeah.
Yeah. So, why is this a teardown? You just had one, or you actually developed one?
I just had one. I was looking for another development kit, so I opened my tub of development boards, and I went, "Hey, here's these old PC 104 boards."
Nice.
And I thought, will they still work? So,
that thing's gonna work till the apocalypse.
Spoiler alert! I managed to, but the video, like, I found the original documentation online for the board, right, for the main processor board. This one didn't have video build on, so I had a separate video card. So I plugged it on, but I couldn't find any documentation for the video card. So I had to probe it to get the pin outs of the and didn't have a VGA connector on the side. Oh no, it had
you
some
had to, like solder your own wires.
I had to chop a VGA lead and solder it on.
Got it.
And everything.
But you got it.
I got and it booted. Yeah.
Nice.
Well, no. It gets to no operating system found. Press any key when ready.
Oh, so it powers up, but
it powers up.
So just go write some code. You'll be fine, right? I mean,
you can't just write code. You've got to install an operating system to boot from. Now it comes with, and this will bring back memories for a lot of people. One of the disk on chip from M Systems. Do you remember that?
No.
Oh, yes, we got him, folks.
That's not hard. The PC 104 is just a lucky thing, and probably you mentioned it on here. That's why. Yep. So
anyway, the M Systems was with the company, and the disk on chip was a 28-pin DIP chip, and it was a complete flash-based disk. It was like a solid-state disk in a 28-pin DIP package, and it changed the whole industry. It was like, holy shit, we don't need a hard drive to hook up to our embedded system.
Wait, but what was it? Is SRAM? What was it? Or like?
No, it was actually flash. It was very early flash.
Oh, really? Wait, really?
Very early flash technology, yes.
Wow. How much? How much memory?
Oh, not much. Like 8 meg or something. Like a gig. No, it wasn't gig. No, it was 8 meg.
Meg even sounds like a lot too.
8 to 32 meg.
It wasn't like battery-backed SRAM or something like that.
No.
Okay,
it was actually flash disk.
Was it NOR flash? Was it?
It's not. I don't think it's the modern version of.
Yeah. It's not multi-layer NAND flash. All that crap. That's
all of our phones. No. I think it's like it was very early flash technology. So I'll send you the link. Here it's USB. Blah blah blah. Anyway,
disk on key. What's disk on key? That's another one.
Oh, disk on key. I don't know about that one. I was like disk on chip was the only one I really used. Yeah. Anyway,
okay.
yes,
Well,
they were from 16 meg upwards. So yeah, but that was plenty to run DOS and an app. I mean, DOS booted in 100K or something.
Oh, really?
You
Okay.
know? Oh, yeah. DOS was quite small. If you especially some of the other flavors.
I bet this was not cheap.
Oh, no. These disc on chip
thing.
things were expensive. They were like a premium product.
Right.
Anyway, that died in 2007 when
they became
things started.
SanDisk. They got bought by SanDisk.
They got
which makes
bought
sense.
by SanDisk. Yep,
Yeah, okay.
exactly.
Yeah.
So anyway, that was all the rage. So, but now, like you take for granted these days that you can just plug in a USB key. Right? These things don't have
does
USB
that anymore?
Right? Well, USB wasn't even invented back then, right? So this thing has like a floppy connector, and in the box came a 3.5-inch floppy drivers and stuff.
Yep.
So I've got an old style PS2 keyboard with the 5-pin DIN connector. So I've got to bodge up. I've not only got to find a PS2 keyboard, I've got to bodge it in from the PS2 to the 5-pin DIN, so I've got to make up an adapter cable. I'm not sure if I have one anymore.
Wait, what's DIN? DIN's like dual inline, but right?
DIN connector. You know, the circular DIN connector back in the day that used to connect to all the tape drives, the audio DIN connector.
Is that the one that looks like a MIDI? Is it a MIDI thing?
Yeah.
Okay.
Similar. Yeah.
5-pin DIN. Yeah. That's what I think about is...
Yeah,
that's a MIDI connector. Okay, that's what I think of.
Right.
MIDI might be a little different, but that's what I think of.
Yes, right.
Yeah, okay.
So similar, yeah. Okay. Circular DIN connector.
Yeah.
Yep. Anyway, so I've got to convert it to that just to get a keyboard running, and then I've got to read the documentation to figure out how to get DOS installed on the disk on chip. And then I might have to bodge in a 3.5-inch floppy drive or something just to get this, but anyway, it's fun. and
I mean, I guess when you tell me you're busy, I didn't think you were saying this stuff, but
no, right.
This is good content. I'm sure you're making a video about this, right? We're going to see this on video at some point.
Yeah, I've already shot some video this morning.
Great,
I haven't actually got the disc on chip working yet, but I'm assuming. Well, I assume that'll still work after 25 years. The disc on chip.
Yeah.
Chip. So but
yeah.
Anyway.
Well. Here's a comparison point, some contrast to that. So BeagleBoard just
released something new, didn't they? Some tiny thing,
right? And so the Pocket Beagle, right?
That's right, Pocket Beagle.
The Pocket Beagle already existed, so that was actually a project that was online. It was basically to fit in a smaller Altoids tin, which.
Right.
I still don't understand the Altoids thing personally,
I don't understand the Altoids thing.
Because it's a metal thing, guys. But
I know it's just stupid. I don't get it.
But the thing that's exciting about it, the reason that they did it is that they shrunk down that Octavo system. Now,
what's the Octavo?
I don't think we've talked about Octavo in the past, but that was basically they had made a SOM, I think is the correct
system
term.
on module.
Yeah, I think it's a SOM. Maybe it's a SIM. Not a SIM. But anyways, it's basically they have... Oh, sorry, it's SIP. System in Package, right?
Oh, System in Package. Right,
yeah.
Okay.
So,
yep.
And that was already on... So that was like, if you look at, like, as the BeagleBoard was going through, I think that was on, like, it wasn't on the black, but it was on the BeagleBoard Blue, I think, which is like the motor driver one.
And the memory was integrated on top of the processor.
Not only and the PMIC and the power management IC and a bunch of the passives and stuff like that. So like
so now they're putting is there power supplies in this module? Yeah, it looks like there's power supplies in there, LDOs and everything, but it looks like a chip.
Right. The way for people to think about it is like, imagine you're just making a really tiny PCB and then you're just covering it in black goop, right? That's like the way to think about this.
That's basically what you're doing. Right. That's basically what they're doing.
So the thing that and it's obviously much more complicated than that because you're actually making BGA bottoms and stuff like that. Obviously, this whole thing is a BGA. The thing that I was excited about is this Pocket Beagle is so it has this new SIP on it, the OSD 335X-SM, right? So that's the new one. Yep. But the thing that's exciting about that, there is an entire. This is literally Linux on a chip. So like that is friggin' crazy to me. And then I talked to Greg, one of the guys at Octavo. He said that with this board, or with this chip rather, it's 256 BGA. It's got the 3 rows of BGA. I think it's 0.8 millimeter pitch. I didn't actually see what the pitch was. Yeah, 0.8 millimeter. No, that's not right. 127 millimeter? That doesn't sound right. What is the pitch? But I don't know what the pitch is, but it's workable.
It is a 1.27 millimeter pitch. That's huge.
Oh yeah, okay. So wide pitch. Yeah, it is that. Right. Okay. So it's bigger. So most of the BGAs these days is 0.8, right? So that's like and smaller. Obviously the 0.4 is really tough. So what Greg was saying though is you can escape all 256 pins with a 6 mil space and trace. You can escape all pins on the top layer, which is
on the top layer.
That's crazy.
That's great.
That's a big deal. So now you have a Linux chip that runs on a 4-layer board.
People don't realize what a big deal escaping BGAs is.
Right.
Right?
Right, exactly. Well, you do, obviously, right?
Yeah, no, of course. That's why I'm saying.
Right. Yeah.
Right? Because it's an important thing, because it forces you, if you choose a chip with a specific pin count and a specific pitch, that forces you into using a specific number layered board.
Right. You're either going to have an 8-layer board, or you're going to need to do like a 3-3-3 space trace, right? Yeah. And it's like, and that gets really expensive, and obviously there's a lot of other design issues. Like it's crazy.
So this could go on a single-sided board. Sorry, a standard double-sided board.
Well, it could, but you really should do a 4-layer, right? So you can get a plane. So you can get a... Oh, okay. Well, challenge accepted, I suppose.
Because it's got the integrated LDOs with the bypass caps inside the module. I'm looking at the photo now, right? So that should be okay. I think you can get away with this on a double-sided board.
Well, that's even more interesting. When I talked to him, he said it was 4, but yeah, maybe 2 would work. Or maybe 1. I mean, I don't know. But either way, even at 4, that's crazy, right? And so this is that same thing we were talking about at the beginning. It's like it's all getting pulled in. And so the other thing that I'm sure that you have thoughts about is the fact that you don't have to do any of the DDR routing, right? It's got DDR3 in there. And you don't have to do any of the routing. That's crazy. Yep. So like even a Raspberry Pi has external memory. Wait, no, they do flip chip, don't they? But it doesn't matter. You can't get the Broadcom chip either way.
They use external memory. The Raspberry Pi uses external.
Yeah, but it doesn't matter. You can't get those chips anyways, right? So this is like a purchasable chip, and like that's pretty awesome. So
what are all the pins? Are they just IOs?
I think so.
Right.
I don't know.
because it's a system on a chip, right? You said it. It runs Linux, so like the pins must be like USB inputs, IOs, maybe an Ethernet to have like Ethernet Mac and stuff built in.
Yeah.
All that sort of jazz.
Yeah, it's got all that stuff.
Data sheet. Here we go.
Yeah. I mean, so on board, it's got 8-channel ADC at 12-bit. It's got DMA, 2 SPI port. I mean, it's got everything the BeagleBone's got, right? But 2 cans, 3 I2C, 2 SPIs, 6 UARTs, 114 GPIO. I'm sure some of those are taken.
6 UARTs.
Yeah. And I'm sure that some of these duplicate, right? So people should, whatever. But then the USB 2 on the go. Right. What else? So like, But the
Ethernet 10, 100, 1000.
Yeah.
2-port and switch. Oh, 2-port.
So here's the thing. I have been seeing people, friends, family, everyone, right?
Your mum's using this.
No, they're designing products with BeagleBones and with Raspberry Pis in them. And Raspberry Pi has a thing like this too, right? Raspberry Pi has a compute module, and that's like you can buy it as a DIMM, like a SODIMM module, right. and that's a good step towards it. But you still couldn't buy the chip, and as far as I can tell, you'll never be able to buy a chip. Now you can go and do something like the chip, right? So that's the Next Thing Co. Yep. They have their boards, and then they have the GR8, the Great, which is like it's I forget what the processor is. It's one of the cheap one, the MediaTek maybe. So it's the MediaTek processor, and then it's a module breakout. And so again, you can buy the processor on a breakout, and you can integrate that. And so that's probably close to this as well. It's basically a similar kind of thing where it's not integrated in a package, so it's a little bit bigger. But still, you could buy it and get it in your product, whatever. But like this, you need to be able to. So the thing I keep thinking.
Can you buy it on DigiKey?
Yeah.
Or Mouser?
Right.
Yes, you can.
Yeah. Or if you can't yet, you would be able to. Which one are you talking about?
The Octavos system.
Yeah.
The thing we've been talking about.
Yeah, you can buy these.
Really?
Yep, I think so.
I'm going to verify. Trust but verify.
That's fine. Yeah, on Mauser. There it is.
I've got a dev board.
Where it's listed. Order now. Order now. I see a link.
Order now.
293 can ship immediately, and you will pay. And you'll pay through the nose for them.
I was just about to order some stuff from DigiKey. Maybe I should order some of these chips and do a little project with it.
Yeah, well, that's what I'm thinking, right? I mean, like, that's what's crazy about it. So, like, and I was talking to Jay. So we've had Jason on the show in the past, and I'll link to that. And I asked him to come back on at some point, Jason Kreidner. But since we had him on way long ago, 3 years ago, they switched to doing. It's all Debian now. It's not running. So it's just stock Debian, which Raspberry Pi also does. And so, like, okay, so I'm obviously at a higher abstraction layer than I used to be, right? Obviously, I'm meeting a lot of people that are doing, some heavy duty processing. Maybe they even want to write with, interpreted languages and stuff like that. Mm-hmm. And that's just the new reality we live in. Assuming you're working off of, a big battery or you're plugged into the wall, then running Linux is fine, right? It's not great, but maybe you want a display, or maybe you want some of the other, security stuff in Linux. So the next step is like being able to make something you can actually make. And if you can actually buy this stuff, that's a good step. So that's all I'm saying.
It's pretty sweet. It's got over 100 components integrated into the one package.
I know. It's so crazy. The other thing I learned, I kind of knew this actually already, is that, what's his name? The guy who invented, so one of the founders of Octavo is the guy who did the Speak and Spell.
Really?
Yeah, Gene Kranz. That's it. Yeah.
Gene Kranz? Gene Kranz is the Apollo guy. Is it just the same name?
Wait, maybe it's a different name. It's a Gene someone.
Right.
Wait, what Apollo guy?
Gene Kranz, come on, famous.
Sorry. Maybe it's a different Gene. Sorry.
He's the mission controller.
Everybody, above 70 is named Gene. So.
Right. Okay.
Or Morty, or Wally. Yeah. So.
Right.
Yeah. But anyways, one of the TI guys. These are all TI guys. These are all former TI people. So.
Right.
Yeah. So that's exciting. Also
cool.
In the news, I finally met Massimo from Arduino.
Oh, right,
Arduino.
yes.
Arduino. And he's very
I thought
nice.
you met him before.
I probably shook his hand before.
Him?
No,
right, okay.
No, I interviewed Eben at who's Raspberry Pi.
Oh.
Yeah,
okay. Right.
Yeah, I don't know. But anyways, he's very nice. But they just released a bunch of new boards as well. So.
After the shake-up, after the big buyout of... Yep.
Yeah, and it's interesting, too, because, so it's like these smaller modules now. It kind of looks like the Adafruit Feather format. Kind of looks similar to that.
Right. I'll tell you what they should do. They should jump on this and release the Arduino form factor version of this chip, the
that's interesting.
Octavo systems, and get support in the Arduino environment for it. Maybe.
Yeah, I guess.
I
Boy,
it's probably overkill. But
I was gonna say it's like using a howitzer to cut your lawn, man. It's like,
right.
I don't know, But
how much are those chips, by the way?
$40.
How much are they?
They're not cheap.
$40.
It's $40 for one of them.
Yeah.
So it's it's more expensive than a Raspberry Pi computer. So
right.
But I think it's probably 20, 25 if you get it in volume kind of thing. But you can get them in volume. That's the other thing. You know what I mean? Like,
yeah.
These are this is just the message, and not for you, believe me. But man, I watch people do this, and it's like, you just see you see 2 years into the future when they're like, oh, we can't buy any of the stuff we designed into our product. Yep. This is a product, man. Like, think about it. Oh yeah. Yeah. So, yeah, exciting. Gene, what did I say? I said Gene Kranz. It's actually
Gene Kranz.
Gene France. Huh.
Right.
Yeah. Speak and spell. Gene France and Gene Kranz.
Got it.
Yeah. Sounds like the beginning of a joke. You know what else sounds like the beginning of a joke?
Oh God. What?
I posted this and someone downvoted on our subreddit. Two fish are in a tank. Right? You ever heard that one before?
No, I haven't. But
two fish are in a tank. one turns to the other and says, "How the hell do you drive this thing?" Right? You don't know that joke?
No.
Yeah, it's wordplay, But then there was a project
stupid.
where a bunch of students built a fish actually driving a little robot that with a aquarium on top of it. I thought it was clever. I'm full of dad jokes today.
It'd be clever if it was monitoring where the fish was going visually, and then the fish was actually controlling the thing. That would have been.
Actually, it is.
Oh, really?
Yeah.
So the fish does actually control the robot.
Yep.
Right.
It's not doing it with vision. It's doing with like light detection. But yeah.
Oh, right. Yeah.
It uses the it like normalizes it and then.
Right.
Yeah. Nerdy. It's good. It's good stuff.
Oh God. Okay. Very good. All right. Do we have anything on our list this week?
Well, that was on the list.
Right.
Yeah. What was good here?
You can tell we didn't prep this at all.
No, we didn't really prep much.
Much. At all.
I had posted. So this is actually a fun project I saw in town. So Bart, who used to be at Instructables, he retired from there, and maybe I mentioned him on here before. But anyways, he just spends his time like making robots now, and they're awesome. His buildlog.net, if people have never been on there. But he showed up at one of the meetups I do here, and there's a link to the post about this thing. It's called pen/laser bot controller, and so he shows up to this meetup that I do. It's at a bar, and we're all hanging out, and he's got this like orange box, and it's like 3D printed, and I'm like, Bart, what is that thing? He's like, check this out. He puts a coaster. He has a set of coasters with him. He puts a coaster into it, and it's got a roller, and so it kind of like sucks the coaster in, and then it cuts out a design. It's a laser cutter, and then it pushes the coaster out the back. And he built this thing in a couple days, and it's just
that's cool.
Oh,
that's cool,
man.
That's
That's part of the story. The other part is then it broke while we were there, and so he's like troubleshooting it while it's getting dark outside, and then he's got the hood open, but there's no interlock, and so I'm looking at what he's doing, and then the laser kicks on. I'm like, oh my god, my eyes! But it's like a 2-watt laser, so no harm done, I suppose.
No harm done from a 2-watt laser. Okay,
was it 2-watt? Maybe it was less than 2-watt. I don't know.
It's 2 watts is like going to burn you, like severely damage you.
I guess so. I mean, it was pointed down as well. It wasn't pointed out at me or anything.
Right.
So, yeah, that's a good one.
Got it.
I don't know.
What's this?
Yeah.
What's this article about? What working at Pebble taught me about building hardware. Have you read that?
Eric
What's
McGoffsky.
the takeaway? Is there a takeaway? Is there a TLDL?
Yeah, but it's the same old one.
What? Hardware's hard?
Hardware's hard, yeah.
All right.
Yeah.
Yep.
I mean, he talks about, like prototype early, of course, right?
Duh.
Yeah. And I should reference, too, oh, shit, what's his name? Oh, he was a case guy, too. I've already forgotten. We had a Pebble guy on the show. Damn it.
Yeah.
Pebble, the amp hour. I feel bad now. I feel really bad. Andrew, I'm sorry. Andrew Whitty.
We've done 300 shows.
I know, yeah. But, he's from my alma mater. I should have remembered. Anyways, Andrew Whitty, we had him on the show, and he was the CTO, and obviously Pebble is no more. They're all part of, what's it called?
Yeah, they got sucked up for a song, didn't they?
I think so, yeah. They're part of, Fitbit. They're at Fitbit.
Ah, Fitbit, right.
Yeah, so some of them are still there. I think a lot of people got laid off, but... Yeah, I mean, I don't know. Pebble did a lot of things well. They were one of the very early. They did Kickstarters very well. They did 3 Kickstarters.
Yeah.
Right. But he's talking about get to China if you're going to be building in China, obviously, right? I mean, I don't like this kind of stuff because it makes it feel like China's the only answer, but they're in the consumer space, so China's probably the only answer, right?
Well, my new meter's being made in South Korea. Thank you very much.
Yeah, but that's not the consumer space. That's what I'm saying, right? I mean,
okay.
Right. And if you're in the industrial space, you could. I mean, or if you're in the educational space, right? So Adafruit's in New York City, right? I mean,
right.
And it's all about the margins about where you're going to manufacture you know, it's more dependent on margin, I think, and what your expected stuff is. China is going to get you the margins that you need for consumer, but
sure,
right. But you're probably not going to have enough volume to go there if you are industrial. So you should probably stick around locally. That's why I love industrial. It's just better.
Yep. It's a world of hurt, consumer. Like, you know,
it really
it's like it's great if you pull it off, but otherwise it's going to be a world of hurt.
Yeah. Well, neither of us have done it, so I don't know.
I mean, we've had Jerry on the show before, you know, talking about the insane pressures of you know, working on consumer toys, which is probably one of the worst.
Right,
you know?
Exactly. Talk about thin margins.
Yeah.
And we're supposed to actually talk to Jerry again too. I had messaged her about stuff,
cool.
So we might have her back on soon.
Sweet.
Get an update. But yeah, I mean, most of the stuff that we cover is kind of, I mean, it's all over the place, right? We have security people. We have, you know, I guess the interesting crossover one, I guess Jurgen, when he was on here, he was the one who was doing, I think you weren't there for that, but he was the one doing hearing aid chips, right? That's kind of, that's consumer in that it's widespread, it's kind of high volume.
Yeah, but they're high priced.
Right.
Like it's not like they're selling. Like, it's not like you can buy maybe you can buy a $10 hearing aid on eBay. I don't know, but they're probably going to be crap.
Right. So I mean, I guess other people so we've had Bunny on, we've had Zach from MakerBot. I guess we had Scott Miller on, right? So we had Scott Miller on. He did the Roomba stuff at iRobot. So I mean, it's kind of all over the place though, and it's even a bigger deal when it's like how much is a watch going to cost, right? It's like if you're Apple, you get to sell a $400 watch, but Pebble wasn't. Pebble was selling a $99 watch. Mm-hmm. So that's a good question though. Right, Pebble was always selling on the premise of we'll have this ecosystem where we make money on the back end of software.
Right.
Has that worked? The app. Has that worked for anyone? You know what I mean? That's the story of hardware startups. Is well, we'll make it up in data, at the end.
Well, it famously worked for Apple, right?
Right, but they're Apple. They make a lot of money in the hardware too.
Exactly. yes, they do. But only because they got to the point where they got so much cash from all the software and everything else that their hardware became better margin.
They had the lock in at that point, then they could.
Yep.
Yeah, I don't know. I'm still looking through our guest list here. By the way, we have a
guest list.
Yeah, you can get to the guest episodes if you go to on the amphour.com. If you go to for you and for us, obviously those are the two choices. For you, and then go to guest episodes. It'll list out all of the episodes. I'm not seeing many here, man. We don't really we don't have many. Consumer people.
I'll just get to work on my micro watch again, won't I?
Yeah.
I'll make a consumer. I'll do a Kickstarter for a watch.
Yeah. Well,
geez, that'll be novel, won't it?
Yes.
Oh man, I was very close to actually producing that. To go ahead and actually producing that micro watch.
It's for a pretty narrow audience, isn't it?
Yeah, but this was nerds? Before crowdfunding. Yeah, it's for nerds. But this was before crowdfunding even came along. It just wasn't a thing. I would have just sold it myself. Yeah.
Yeah, so when you lied to vendors about how many you would use per year, what was your lie?
10,000,
Oh, okay. That's still small
potatoes, I sold quite a lot. Yeah, small potatoes.
Right. Yeah. I mean, that's the thing. It's a lot. It's a lot to me. Yeah. Right. It's a lot in the industrial space, but for a consumer, that's nothing. You wouldn't get anyone's attention.
No. Of course. Yeah. Chump change.
7 figures of devices, right? That's the.
Yep.
That's when you get the price breaks. So yeah.
Consumer. Anyway.
Yeah. So go to China early, I think is the main lesson is go early, get your hands on, right? Get out in the field, I was reading those what's that, Steve Blank? He's the startup guru guy that taught at Stanford. He's the one who taught Eric Ries.
How many startup gurus
but Eric Ries was in his class.
Oh, so there's some Uber startup nerd, is there?
Right. Well, yeah. People this is an actual example. Don't worry about that. I mean, like, yes, there's a lot of people that are like, oh, okay, buddy, but this is actually like he's legit. I think, yeah.
Right.
But basically, he kind of talks about what Jerry talked about. And actually, that's what Jerry. So Jerry was the guy I couldn't remember a couple weeks ago. He's the one who did that industrial Sivionics, right? So Jerry was from Sivionics, and he was talking about like, you have to get out of the building, right? And he was the one who would help people. Remember, you and I were talking about like, oh, like Jerry should do a class teaching people about this, like how to do product development stuff. And he was basically quoting a lot of Steve Blank stuff. And that's the idea is like, and this is what Eric Migovsky's saying too, is that you just got to get out there and not only get out there and talk to your customers, but get out there and talk to your manufacturers. You need to get on the floor, right? Yep. This is the stuff that Ian talks about. Ian, a dangerous prototype, who lives in China now, and like you know, like you need to be near your stuff, or else you're going to have no context. You're not going to know what they're doing. You're not going to have any way to control what's going on. So,
agreed.
I'm surprised you haven't been to South Korea yet, honestly.
Oh, all right. No, yeah, exactly. I haven't been.
Is that going okay? Like being remote?
No. There's been issues.
Okay. Yeah, I mean, like,
but it's not so. It's not production issues really. It's more design issues.
Okay.
So you know.
Well, and I guess the difference too is that you didn't dictate the design from the beginning, right? That you were helping modify an existing design of sorts.
No. It was done from scratch.
Oh, really? Oh.
Yeah. It was done entirely from scratch. Yes.
Oh, color me impressed, sir.
No,
okay.
This is not based on any existing multimeter design at all. But you know, obviously they take some building blocks, you know, like
sure,
maybe,
of course.
But you know,
right.
But basically, no, it's entirely from scratch.
Okay.
Yep.
Even like the molds and everything?
Oh yeah.
Oof.
Yep.
Wow. Fancy. I'll have to get me one of these. When is this coming out? Ever? No? Yeah?
21st of October will be the first 50 of them.
Oh.
I've ordered 50.
Man.
I've ordered 50. Like an early run batch, you know.
See, now, so so you're talking about, like, so you are skipping both of the things I just said, right? You're not going to the facility, and you're not talking to your customers. You are the customer, right? But
exactly.
So that's the difference there. But
I know my customer base, right?
I mean, you are your customer base, right?
Yes,
you're going for like the test nerd,
right?
So,
yes.
Yeah,
exactly. So I like to think I know what I'm doing there.
I guarantee you do. I mean, like you're going to be your harshest critic. Well,
right.
No, it's the internet. You're going to have some harsh critics, but
yeah, exactly.
But the not being on site, I mean, you have built some trust by, like, you private labeled some of the stuff, right?
What do you mean private label?
Isn't this the ones that have the what's the blue meter that I have? Is it the same company?
That's the Bryman. No. It's a different company. The Bryman one's just an existing model rebadged with mine.
I thought it was the same people. I'm sorry. Okay.
No.
Okay.
Different company.
So, well, this might still all blow up in your face, right?
That's it. Well, it could.
Yeah.
Well, you know.
I mean, you've had some on-site stuff, right? You've had some devices in your hands, so.
Oh yeah, no, we've gone through. I've got 10 different prototypes. You know, yeah. So I can see what hardware they're actually producing. So it's almost like, you know, they're contracted to sell it to me for a price. I know, like, they're brilliant at giving me hardware, so that's why I'm ordering 50 up front right now, just so as like a test.
This is like a pilot run, yeah.
It's basically a pilot run, yeah.
Right. Are they tooled up to do this? I mean, like, so.
Oh yeah.
So this is like an acceptance test almost. I always forget the names of the.
It depends on
what is
who
it,
you talk to. What names they use.
PTV, the verification testing, DVT, design verification testing. DVT, PVT, right?
All that crap. It depends on who you are and who you work for, and as to what acronym you use.
Yeah, but this is going to be like an early production.
This will be basically the first production run, pretty much.
Yeah.
You know, because they're setting up the proper SMD line. You know.
Okay. Yeah. So this will all be. Yeah. This will actually be machine placed and. In theory, if all of the supply chain was in place for this and the parts are on order, you could say, "Yep, go."
Yeah. No, well, in fact, the last couple of prototypes they sent me have been from the actual pick and place machine.
Oh, nice. Okay.
Yeah. So
that's great.
You know, So they are practically finished products.
Mm-hmm.
Yeah. So I know exactly what I'm getting. So unless something goes wrong, I don't necessarily have to be in the factory because they're, if anything goes wrong, the onus is on them. But of course, I'm the one who's actually promising these things by a certain date. So, it'd be handy to go there, but it's South Korea.
Well, so I
It's
think
not
this
like
is a little bit different too. So like this was like a partnership kind of that you were approached with, right?
Well, I approached them and said, hey, because we were talking about other things, and I said, hey, I've always wanted to design my own multimeter, and they went, oh yeah, we could do that, and just send us some specs and we'll give you a quote. So I sent them some specs. They sent me a quote for a finished meter, and they came up with a concept of what it would look like. I told them what size I wanted and stuff, and and then a lot of to and throwing.
Yeah, right.
Over a lot of time and effort. And
I mean, it has been going more than a year, right? I mean, like
but like it's not that I contracted them to do it. They basically said, yeah, we will do it, and we'll pay for everything.
Oh wow!
And
okay.
Yeah,
See, that's different.
I haven't spent a cent on this.
That's different, people.
Yeah,
right?
no, So this isn't traditional. I've not spent a cent on this, right? And they've been working on this for 2 years.
Right. Well, you gave like IP, right? Obviously, they benefit from
they
brand and IP.
That's what they wanted. Well, they wanted two things. One, they wanted to sell multimeters, of course, and they believe that with my my market, so to speak, I can sell quite a lot of multimeters, right? So they think they should make some money that way, right? So assuming it's a winner, it should sell quite well, hopefully. That's that's a bit of risk on their part, and well, that's a risk on their part.
Right, yeah, because they're paying for tool. I mean, they're going to own the tooling. They're going to own the.
That was part of the stipulation. They said, "Hey, we're paying for all this. Can we use the tooling for other non-competing products?" And I went, "Yeah, fine." Yeah. So they're going to.
I mean, they just can't. They can't brand it with your name.
Oh no, they can't brand it with the name, and they can't sell a competing multimeter in the same form factor.
Yeah.
In the same case with the same tooling, but they can go sell like a power meter or some other meter that uses the exact same case with the 4 AA batteries and the whatnot, so that's one thing they wanted from me. Obviously, is to sell meters. The other thing they wanted is my expertise in the multimeter market. They wanted to learn stuff from me about designing multimeters so that their own products can get better. Like not only in terms of features, but in terms of, testing, debugging, what stuff were, and all that sort of stuff. So they've learnt a lot from this as well. So that's what they're getting out of, and I'm sure that that's why they want to maintain the firmware. They want to, like I asked them, look, hey, should we take the firmware off your hands? Should we still we maintain this firmware ourselves? And they said, no, we want to do it ourselves because we want to, we want to develop code that we can use in other products and stuff. So,
Okay, so it's like mutually beneficial.
Mutually beneficial, yes.
That's great.
It cost me nothing with almost no risk, well, very little risk on my part, and larger risk on their part, but hopefully a larger return for them. So
right, yeah. That sounds like a.
Well, it's good.
As long as everybody abides by the contract, I'm sure it'll work out fine.
Well, yeah, I mean, they've increased the price a few times because we've changed a few things, so it's more expensive than originally intended and stuff like that. And technically, I could just pull the plug, right? I could just pull the plug after a couple of years, and they would probably go, well, we're going to sell it under our own brand because we've paid for it. Right.
Yep.
So it'll happen one way or another.
Yeah. Yep.
Not that I'm going to pull the plug.
No, at this point, why would you? Right.
No, but technically I could, So,
yeah. Well, I mean, that sounds like a sweet deal.
It's a pretty good deal.
That is to say, most people don't get that. So.
No, see, that's why I've mentioned on previous episodes, that's why I'm not whipping them, right? Because this is not my money on the line, it's theirs.
Right. Well, and also you don't really I mean, like, your timeline is somewhat, fake. Like, it's you promised it, and that's important. But it's not like, well, I set it up, like all this PR campaign or something, right? You're gonna do a Kickstarter campaign when you're
I will do
ready
a Kickstarter very shortly.
Yeah, right.
Yep.
That's
not
exciting.
looking forward to that. No, it's kind of exciting, but it's a lot of work.
I don't know, man. You got to watch out. Do you know how to make videos?
No, I don't know. Well, I don't know how to make good videos. I know how to make videos,
right?
But,
I think it would be weird to see you in a highly, polished,
highly produced video.
Yeah, that would be really weird.
Yep.
It'd be like, hello. I'm David Jones. Welcome to the Multimeter Factory. And then, like, harps play.
Right.
Brum, 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 brum. I kind of want to see that now, but it wouldn't do well.
Right. No.
Yeah.
Anyway, so yeah, that's the story of that.
Yeah. Well, we're talking about all the same things here, right? Like, if you're going to make a product, make sure you can build it, right? If you're paying for it, if your ass and money's on the line, then you want to be there. Yeah. Right. Yeah. Exactly. Right. And especially if it's consumer, probably don't do consumer. That hurts.
Yeah.
Right. Yeah. Oh wow. Okay. Well,
but there are lower risk. Like, some products are much higher risk than others. You know, if you're just getting like a hat, if you're just developing like a shield, if your product's just a Raspberry Pi shield, which is a few parts on a board, right? The risk is, much lower than something that has, injection molded cases and complex test procedures and complex calibration procedures and, complex stuff in the production environment and, critical parts and etc.
Right. Yeah,
they're almost chalk and cheese.
It's almost like how there's like the different layers of bombs, bills of material rather. Like it's like the top line bomb. It's almost like we should have the amp hour law. Like, as the top line bomb number increases, the complexity of the product scales by square. Like, it's like a square law type thing.
It's a square law.
Yeah, right.
Yeah,
it's like, oh, you're putting a screw into that PCB, right? You probably just got 4 times harder just for that one screw. You have a screw and a zip tie. Oh, sorry, you're at 8x now.
Well, the micro supply, which we're working on at the moment, we changed not our topology, but we changed what the product, like, we changed sort of the top level spec of the product, the top level, how it, what am I saying?
Yeah, like the deliverables or the data sheet that you would write, that kind of thing. Like this.
Almost
the feature set?
The feature set and the usability of the thing.
Oh, okay.
Right.
So totally unusable now.
What. Yeah, no, I'm not going to say what, but we basically it's used differently to what we previously envisioned with the previous designs, and some of that was to like.
Right. Well, so like, if I could conjecture, you were talking about battery powered before, so maybe you ripped the battery out, or it was, you changed the voltage range, or you do, some other big feature set type thing, right?
You're getting warm, yeah.
Getting warm, right? Yeah.
Yep.
Right. No, but that's good.
Stuff like that. Yeah.
That's how you modulate schedule, right? I mean, that's what. Yeah. If you want to change your schedule, you change your feature set, and then and this is again to go back to what's his name, Steve Blank and Eric Ries and the whole lean startup thingy, right? If you want to get something out faster, make it simpler, because the truth is most people are going to tell you it's a piece of shit either way. And that's what you're really trying to get towards. That's basically if you had to summarize that book, it's put the crappiest thing you can into the market as fast as possible, because people are going to hate it no matter what.
Exactly. And that's what we're trying to do. Not only will it speed our time to market, it'll make it simpler, it'll make the housing simpler, it'll make compliance simpler, it'll make, there's a lot of...
The problem is when you make it, and you make the simplest thing you can, and people love it. And then they say never ever ever change it. And you're like, oh, come on.
Yeah. But come on, this is crap. Right.
That's when you double the price.
Yeah.
and then you make the next version.
It's kind of like it's like my microcurrent.
Yeah.
Right? That was never designed to be a mass produced product. It was designed to be an article for a magazine and a one-off for me. And I'll sell a couple hundred kits maybe. Yeah. 9 years later, I'm still selling that damn thing.
Yep. What, is on version 2 or 3 or something? I mean, you've changed a couple things. Yeah.
I did the microcurrent gold. I upgraded that.
Oh,
but
that's
basically,
right. Yep.
But people just, I didn't expect that form factor and that feature set to be popular.
Yeah.
It's just what I needed at the time.
Right. Well, I mean, it's like if you're making good products though, and you have the capability to put a lot out, right? It's almost like a throw it at the wall and see what sticks, right? Obviously, you're still solving a problem, but that obviously solves a problem. So, and that's what resonates with people.
Exactly. Yeah. So it didn't need anything more refined or better.
Having a distribution method such as your face on camera doesn't hurt.
Oh, right.
But but that's also a benefit, right? That's like a built-in marketing channel. So
true, but you got to remember, ever since I've had the blog, right? I had I was selling the microcurrent before I started the blog. Right. And then after I started the blog, I actually discontinued it twice, even though I was effective. Like I did videos on it and stuff. I actually discontinued it twice because the interest dropped off. So I thought, discontinued. And then all of a sudden interest just comes out of nowhere. I get 100 people emailing me and like out of nowhere. And I go, I'll do another one. And it leads to another one. And
that's a great way to actually get people to order something, by the way. Is to announce obsolescence. People will be like, "Oh no, I need one. I was waiting."
No, I need one. Yeah. And artificial scarcity too.
Yeah. Oh yeah. Yeah. Right. You put a counter next to it, and 30 left, 29, 28. Yeah. Bye.
Psychology 101.
Right. Exactly. Suckers.
Yeah.
Yep. Oh man.
Ah boy. Anyway, the joys of product development.
The amp hour is, well, not even the amp hour. It's really your stuff. I'm not making anything.
Right.
Yeah. The EEV
for
blog.
once, I'm doing a lot more than you.
Yeah. Hey, look at that. Yeah. I don't think for once. I think, it's been a slow burn, man. It's been a slow burn.
Yeah. I'm consistently slow.
Right.
burning.
Yeah, that's right. Dave is the tortoise of product development.
Right. Yep. Well, that's it.
Yes.
For a show.
One other thing. Usually I said I wouldn't do this, but we've done it in the past. I've been doing it recently. Speaking of product development, Zach, former guest of the Amp Hour, Zach from Kickstarter, he has a new podcast, and it's about product development. So it's called, it had a good name too. I don't remember what it's called. Nope, that's not it. Back to Zach Dunham. Where is it? The Prepared. That's a good podcast name.
The Prepared?
Yeah.
It sounds it sounds like
a zombie prepper movie kind of.
It's a zombie prepper movie, yeah.
Yeah. But anyways, I think it's good. I like it, and he's.
Why couldn't not the Prepared? Because that implies people. Why couldn't it be tech prepared or something? Or
I think he's a little more design minded than we are, Dave. Like this is going to be
production prepared.
This is going to be outside of our circle as well, right?
Right. Okay. Right.
So yeah. Okay. So like I'm looking at he has one of the BioLite people on.
Right.
Which is a cool little product. I was very unsure of that thing. I thought that was going to be snake oil. That's a cool little product. I don't know if you've seen it.
BioLite.
It's like a camping stove that converts. I mean, it's really just it's like you put like twigs that are burning into this little chamber, and then it's just not a Peltier, maybe a Peltier.
Oh God! No, it charges your bloody phone, and
it does. I mean, like that's
your coffee.
Not makes your coffee, but yeah, but. So I thought the same thing at first, but then go watch AVE's teardown. So AVE did a teardown of it, and he actually did this. He was hardening his as well. For some reason, they don't conformal coat it, and so he hardened his design. He did conformal coating inside, and I was like, oh man, that's gonna stink up the room.
Yeah. Oh, that stuff's awful.
Do that stuff outside, folks.
Definitely.
But AVE, come on, he knows what he's doing. Sometimes we love him. We love him.
He's cool.
Yeah, and it's a nice little product inside. I mean, it's cool. So, I don't know. I think it's a neat device. If you think about charging LEDs, stuff like that, like
man. No, maybe I'm jaded because I was approached by a company that's selling one of these things, and I had email discussions back and forth with the head technical guy who's developing it there. It's like it's designed for third world countries. It's got a peltier, and you whack it on a stove and you fill it with water, and so it dissipates on the cool side, and it charges your phone and generates light and power and whatnot. No, I don't know. I'm so.
I mean, you got nothing else though. I mean, if you don't have sun, I mean, like, okay, say I live in the Midwest, right? Like you go camping, I know. You got a lot more fire than you do sunlight. You know what I mean? Like. And lugging batteries around ain't always the best idea. So.
Yeah, I know. But they think, it's going to take over the world. And it's like,
no.
Niche,
I think that's the big thing. I remember I had a friend that worked on an energy harvesting thing, and it was like, that's always the problem is that the promises are of the top line specs like we talked about, those are always just way out of line, right? They say they can do 5 watts or something. It's like, okay. Like on the best day ever. And that's
on the best day ever with holding your tongue at the right angle while farting Dixie at the same time.
Exactly. Yeah, you can't. Yeah, I mean, like that's a bad way to spec products, but sometimes in crowded markets that happens. So
it happens by rule almost.
Yeah, that's true.
It's
a consumer product.
Is there a market? Is there a market that is devoid of that? I don't think so.
Specsmanship, one-upsmanship. Yeah.
Yep. No, it's just everywhere.
Yep.
Oh, I want off this planet.
All right. Well, you at least get off the show for this week.
All right.
So
thank you.
Yes.
Right. I'm going back to my PC 104. Back to the old days.
Yeah. Back to the future.
Cool.
All right, man. I'll talk to you next week.
Catch you next time. God, I loved this thing I hated, but loved this thing that Mike tweeted.
Oh, yeah.
Mike, the salt shaker.
That's actually not that new, you know.
Salt, isn't it? But it just typifies the internet of shit.
Yeah.
You know, it's just,
Yep.
It's
right?
the world's first interactive centerpiece and smart salt dispenser, because that's what you freaking want.
Right.
You know,
and the video is so painful to watch.
Too. Oh, I haven't watched the video. I don't think I could.
It's so bad.
Oh, really? Okay.
And even just the name, Smalt. Yeah. It sounds like something that you wipe off your ass.
I know.
Oh, I got smalt all over me again.
I got smalt all over me. Oh man. Just shoot me now.